Question 2 wants us to solve 5 cos 2 theta times cosec theta equals 2. So we need to change cos 2 theta into something else, as well as cosec theta. Now cosec theta is 1 over sine theta, so it would make sense to change cos 2 theta into something to do with sine theta 2. And the identity that we're going to use is that cos 2 theta equals 1 minus 2 sine squared theta, as well as the fact that cosec theta equals one over sine theta. So given those two things, we can now write that we've got 5 times by cos 2 theta, we're going to write as 1 minus 2 sine squared theta, times by cosec theta, we're going to write as times by 1 over sine theta, equals 2. Next thing I'm going to do is get rid of this sine theta on the bottom of that fraction by timesing both sides by sine theta. That's going to give me 5 times 1 minus 2 sine squared theta equals 2 sine theta. Now I can expand these brackets, which gives me 5 minus 10 sine squared theta equals 2 sine theta. And this is one of those questions that we can make look like a quadratic. To do that, I'm going to move, because I've got a negative sine squared term, I'm going to move everything over to the right. So I'm going to add on 10 sine squared thetas. I've already got 2 sine thetas, and I'm going to subtract 5. So that I've got nothing left on the left hand side and everything's on the right. Now hopefully this quadratic in sine will factorise. I'm going to hope that it's going to be a 5 and a 2, and if it is, that means it will be a 5 here and a 1 here. That's going to give me 25, so that is definitely not right. I'm going to undo that, try and think of something else. The only other option is for it to be a 10 sine theta and a 1 sine theta. And again, if it is, that would be a 5 here and a 1 here. That would give me like 50 sine thetas. So that's no good either. So I'm now thinking that this doesn't factorise. And I'm going to have to either complete the square or use the quadratic formula. I'm going to use the formula because of this 10 sine squared theta. It's going to be a bit of a pain to complete the square. So sine theta is going to equal minus 2 plus or minus the square root of 2 squared minus 4 times 10 times negative 5, all divided by 20. If I simplify that, I'm going to get negative 2 plus or minus the square root of 4 plus 50 times 4 is 200 divided by 20, which gives me negative 2 plus or minus 200 root 204 over 20. So I work out those two values on my calculator. minus 2 plus root 204 divided by 20 is 0.614, and negative 2 take away root 204 divided by 20 is negative 0.81. That means theta, if I inverse sine those two values from this one, that gives me minus 54.5, and from the other one that gives me 37.9. I just need to check what the range is between 0 and 180. So if we think about the sine graph, which looks like this, with 180 here, this value of minus 54.5 will be over here on my graph. The next time that I get an angle that's equivalent to that has an answer of minus 0.81 will be past 180. So that's not going to get any solutions from there. This one, however, the 37.9, will have a solution here and will have its next solution here before the 180. So my other answer is going to be theta is 180 minus 37.9, which is 142.1. So those are my two solutions in the range that we've been given.